We've seen in the previous video how to build a scatter plot. Now we're ready to do some calculations. Here's the formula for the R correlation coefficient. It's rather extensive, but if you take a look at it more closely, you'll see that it's actually not so bad. First we have R. Then, on the top part of the equation, we have n, the number of objects, which is multiplied by the sum of x times y. To that whole bit, we subtract the sum of x times the sum of y. Now for the bottom part, if you take a close look, you'll realize it's twice the same thing, except once with x and once with y. So we have n again, times the sum of the squared x's, minus the sum of x squared. See how these two are different? The parentheses here are really important. Now you multiply the first bit by the same thing, except with y. Once you've got that multiplication, you square root the entire denominator, and voila! Now how about we do a full example for calculations? To do the full calculations, the first thing to do is to add 3 columns to your table of results. First column is x times y, and then x squared, and then y squared. So let's start with the easiest part, the sum of x, which is 57, and then the sum of the y's, which is 511. Then we move on to the third column, so x times y would be 6 times 82, 492, 2 times 86, 172, 15 times 43, 645, and so on and so forth until you get all of your x times y's and add them up. So the sum of x times y is 3,745. And then we go to the next column, which is the square of x. So 6 squared, 36, and all the way down to the bottom. Now we want to do the sum of x squared. We add all of those up, which gives us 579. We repeat, but with y, so 82 squared, and etc., all the way down to the bottom. We add them all up, which gives us 38,993. Now we're ready to start changing the variables into our equation. We already know that n is 7, so you just substitute all the n's in the equations for 7. We have calculated the sum of x times y, so we can plug into the equation. And we have also calculated the sums of x and the sums of y. Let's plug that into the equations as well. So now we're ready to go to the denominator. With the sum of x squared, change that into the equation, 579. Now we don't have directly the sum of x squared. All we have to do is 57 squared, which gives us 3,249. We have the sum of y squared, as you can see here, and again we simply square the sum of y, which is 511 squared, which gives us this. So now we have all the values in the equation. We're ready to do the final calculations. First, we can simplify by doing most of the multiplications. So in the numerator, the two terms becomes this, and then in the denominator, for example, 7 times 579, the terms become this. We continue the calculations with the subtractions. On the numerator, it becomes this, and in the denominator, we do both subtractions found in the brackets, which becomes this. Almost done. Now we only have to finish up the denominator. To do so, we multiply the two bottom values, which gives us this, and then we square root that result. All we have left to do is to divide the numerator with the denominator, and we've got our R value. The rounding rule for the R coefficient is to keep 3 decimals. Now here's a clue to see if you might have made a mistake. Remember that all R values are between -1 and 1, so if your calculations bring you elsewhere, you've certainly erred along the way. A coefficient of -0.944 suggests a very strong negative relationship, which is also, if you remember, what our scatter plot was evoking. Again, see how all our points hover very near the line, and how the line dips towards the bottom. Now, of course, the question to ask is this value of -0.944 significant? In other words, considering the number of values, is this value far enough from 0 and close enough to -1 so that there truly is a relationship between both variables? We'll find out in the next video.